So this one's a little bit different. All the questions we've had so far have given us an equation, and we had to draw the graph. Now this one says, can you work backwards? If you had both graphs, could you write the equations? So the graphs of f of x, so the original graph is the red one, had vertical or horizontal stretches and compressions, and a new graph, the blue one, is shown. Write an equation of the blue graph in terms of the function f. So if we were working backwards and we were using the same techniques that we've used so far, what do we know? Well, we had taken our original points. So we have an original point on the red graph of 3 to 9, and we have another original point on the red graph at 2, negative 8, and another one at 0, 0. And those graphs got changed to the blue one. And can you see that 3, 9 changed to 1/2, 4.5? 1.5, 4.5. And 2, negative 8, that changed to 1, negative 4. And 0, 0 stayed 0, 0. Let's look at the x coordinates first. Is there a way that you can change 3 to 1.5? That also works for changing 2 to 1. That also works for changing 0 to 0. What are you going to do? Multiply by 1/2. That's the only way that it would work for all three. Can you see that you could get to 2 to 1 by subtracting 1? But that doesn't work here. And it doesn't work here. What about the y values? Looks like also by 1/2. See how we're working backwards? Normally we would have found the points. Now we had the points, we found out what algebra needed to be done. Once we have the algebra that needs to be done, we make a note. If you're multiplying x by 1/2, that's a horizontal compression. If you're multiplying y by 1/2, that's a vertical compression. Vertical stuff happens outside the function. So if I want a vertical compression of 1/2 outside the function, I'll have 1/2. My function is f of x. If I want a horizontal compression, that has to be inside the function. What number inside the function would cause me to multiply by 1/2? A 2. Right? Because the inside is always the reciprocal. And again, this language that came up, when it's asking for an equation in terms of the function f, that means we have an equation with an equal sign, but on the right-hand side, we have f, the function. Has to show up on the right-hand side. I don't know about you, but I just reread the question, and it didn't say anything about domain and range. And I was happy. I don't know if that happened to you. It's like, okay, I feel like they've domained and ranged us a little bit too much already. So there is our question, okay? Now, I'm going to show you a second method for this one. And the reason I'm going to show you a second method is because, first of all, the second method for this question is not as good as this first method. However, when we get to a little bit more complicated questions, this method won't work. So I'll show you a second method that will work later on as well. Okay? So we'll call it And in order to do this, we're going to go back to our original graph. We're going to choose 2 points on each graph. I'm going to choose this as point A on the red graph and this as point B on the red graph. When we have corresponding graphs on the image graph, we often label them with a little dash. A prime, because that's where A went, and B prime, because that's where B went. So now that we have that, the second method is a way of finding out the stretches and compressions by comparing vertical distances and horizontal distances. So we'll start off with the horizontal distances. On the original graph, if you went from A to B, horizontally, can you see going from A to B goes from 2 to 3, which is 1 to the right? So we would show 1 to the right as a +1. You don't have to write that plus sign, but if it went 1 to the left, I would write -1. Does that make sense? And then when I look at A prime to B prime, I go from 1 to 1.5. That's going 0.5 to the right. Horizontal is x values. I went from going 1 to the right to 1/2 to the right. What would I need to multiply to go from 1 to 1/2? It's telling me my x values had to get multiplied by 1/2. Same answer that we saw before. Okay? If we look at our vertical distances, from A to B, A is at -8, B is at 9. We would be going up 17. If I look at A prime to B prime, from 4 to 4.5, -4 to 4.5, it's going up 8.5. Again, vertical is your y values. And how would I go from 17 to 8.5? I would have to multiply by 1/2. So this would give us the vertical and horizontal stretches and compressions the same way, but not as intuitive as the first one, because the first one was nice because it was exactly backwards of what we did. Okay? But we're going to need this second method later, so I'll refer to it when we get to there later on, but I wanted to show it to you already. And yes, I read the question. There's no domain and range. I haven't given you the questions to circle. So 5, 12, 13, and 14.